Good morning. Happy Friday. This is Captain Coder, and we are about to work on day 9 of the Advent of Code. I usually stream a little bit earlier, but slept in a little bit today, so took my time waking up, getting going. So, apologize if anyone was waiting for me. But good morning. Happy Friday. Let's dig in to day 9 here. This rope bridge creaks as you walk along it. You aren't sure how old it is or whether it can even support your weight. Seems to support the elves just fine, though. The bridge spans a gorge which was carved out by the massive river far below. You step carefully. As you do, the rope stretch and twist. You decide to distract yourself by modeling rope physics. That's a good distract yourself by maybe you can even figure out where not to step. Consider a rope with a knot at each end. These knots mark the head and the tail of the rope. The head moves far enough away from the tail. The tail is pulled towards the head. Due to the nebulous reasoning involving plank lengths, you should be able to model the positions of the knots on a two-dimensional grid. Then, by following a hypothetical series of motions for the head, you can determine how the tail will move. Due to the aforementioned plank lengths, the rope must be quite short. In fact, the head and tail must always be touching, diagonally adjacent, and even overlapping. Both count as touching. All right. So we have a head and tail, just a short length of rope, I suppose. Head and tail, that the head is going to move and the tail is going to respond to that move. If they're considered touching if the head is adjacent to the tail or on the tail. So like a total distance of max 2 if you're counting orthogonal distance. If the head is over 2 steps directly up, down, left, or right from the tail must move in that direction so it remains close enough. So tail has to remain adjacent to the head. If the head and tail aren't touching and aren't in the same row or column, the tail always moves 1 step diagonally to keep up. Okay, so if we're 3 spaces away, the tail is going to sort of make an intelligent move to catch up. Okay, let us figure this out then. So our inputs are going to be sort of the instructions for the moves. The head's going to move right 4, up 4, left 3, down 1. And then, yeah. And then what do we need to report at the end? After simulating the rope, you can count up all of the positions the tail visited at least once. In this diagram, S marks the starting position. So they always essentially start at 0, 0 together. And the hash marks the positions it's visited. So there are 13 positions the tail visited at least once. Simulate the motions. How many positions does the tail of the rope visit at least once? Okay. That's not bad. So we're going to have, I'm going to call them actors. We have like these actors in space and they can move around. And there's going to be 2 type actors, sort of like a head actor, which responds to movements. And then there's a tail actor that updates itself based on its parents. All right, let's give it a shot. We're going to create an actor here. And so our actor, we have public class actor. It's going to be mutable, so the positions are going to mutate. We have and we also need to keep track of the places we've gone. So we'll have actors. We'll keep track of where they've been. So we'll have a position Yeah. So int row public, int row public, int call. And then these, we will have a private set on these. And we will have a move method. So we're also gonna have to have a public, and this probably shouldn't be public here. Visited. This one probably shouldn't be public, but let's see, do I want it to be public? We'll leave it public for now, but we're gonna have a method public move or set position. Public move. To make it simple, I want a set position. Int row, int column. And we are gonna set this row to row, this column to column. Between actor.row. Hang on, something weird's going on here. Saying there's something called actor already. Rope. Ambiguity between rope.row, rope.row. Is this a real error? And then we would do visited.add a pair row and column. This dot visited dot add. Ambiguity between actor.visited and actor.visited. Agent. What is going on here? I'm really confused by that. What the heck? Are these real? All right. Sometimes I get weird. Yeah, those aren't real errors. Something that was, I have no idea where those errors were coming from, but we've resolved them. That was fascinating. Okay, let us continue. So I want to be able to set the position, and then we sort of need to move in sort of a, well, not all actors need to be able to move. We need to be able to process like a step here. All right, so my idea is that I will have some subclasses here. So I'm gonna create a new file head actor. Public class head actor. Because the head's gonna act different than the tail, but it needs those same properties. All right, and the head actor is gonna have just like a basic move. Yeah, so let's create a move enumerated type. So we're gonna do enum public enum move And we're gonna have north, south, east, west. These are our possible moves. And we will update our position. Is that what I want, or do I want my move? Public record. We'll just make a move, take an int, offset row. Yeah, so int row, int call. And we'll just move by that amount. That's what we'll do. So the head actor, you can move it directly. So it's gonna have a move method. And it's gonna take in a move to perform. And performing this move is going to be that we take our this dot set position equal to this dot row plus move dot row this dot column plus move dot column, like that. So it's important that we use this set position because we need to keep track of every spot we visited. So every time we move, it just will track what we've visited here. Okay. And then when the head moves, it sort of tells its child, hey, update yourself. So it's sort of going to be attached to a tail. So it's going to have a tail actor, public tail actor tail, like this, and then we're going to create that new file. Tail actor public class tail actor. It's also an actor. And it needs to know about who it's following. It needs to know about the head so that it can figure out how to place itself. So we're gonna go with a public actor, public head actor, parent, get like this, and then we're gonna have a constructor for our tail actor, which takes in a head actor parent. So this is who we're following. This dot parent equals parent, like that. So our head actor can have a tail, and we're just gonna do tail actor like that. These should all start in position 0, so just for safety, we'll do this. This isn't gonna set the initial position here. Let's make it so that we can construct an actor. So we'll do new or public actor int start row int start column, and then it's going to call set position on our start row and our start call. That way the start position gets added in there. And then we'll make it so we have, oops, wrong button. We are gonna make it so there's a default constructor, which is just gonna be this, like that. It's just gonna call this one with 0 passed in. All right, so that way our tail actor needs to take our parent this. Can I do that there? I'm gonna have to make this, I'm gonna have to initialize this in the constructor. Public head actor this dot tail. Oh, let's make this a property. New tail actor. And then we have to tell it that our parent here. Okay, so we have our head actor, we have a tail actor. The head actor has a tail and the tail actor has a parent, so the head. When we move this, after the head moves, our tail needs to also check for move. Public void, it only cares about its parent, so I'm gonna call this follow. All right, so we'll implement that in a second, but the idea is after our parent moves, then we just call this dot tail dot follow, and that will be the logic to update where our tail moves. And then we gotta keep track of, all right, so we're following our parent. Maybe I should name this head. I'm gonna call it head. All right, so we are following our head. And we'll get our total distance. So there's a couple things. If our total distance is 0 or 1, so our total distance is going to be int total dist is going to be the difference in our rows and columns. So math.absolute parent dot called it head dot row minus this dot row plus math.absolute head dot column minus this dot column. So this is the total distance from our parent, and I don't even call it total distance. So this is our distance. So if our distance is less than 2, we're gonna do nothing. If it's 2, we need to check if we're adjacent to our parent. So maybe I write a thing that says is adjacent. Private bool is adjacent. And then we can say if we is adjacent, we do nothing. All right, so this is gonna return true if we're adjacent. All right, I like that. So if we know we're adjacent if distance is less than 2. So if our distance is less than 2, and then the other one is essentially if our distance is going to be 0, 1, 2, or 3. So definitely, all right, so if dist is equal to 2 and our if our distance is 2, we want to make sure that we've only moved by row or column. I'm trying to think of it. I could write a nasty thing here. If head, yeah, so we'll do int row dist. Hang on, we'll pull this out a little bit. Row dist int column dist, like this, and then dist. We won't recalculate the absolute values, we don't have to. So we have a row distance, we have a column distance, like this, and we're gonna say if our distance equals 0 and cdist equals 2, it's probably a nicer way to write this. Oh, here we go. If our dist is 0 or our dist equals 2 and cdist equals 0. All right, so I think that covers it. There's probably a nicer way to write this expression here, but I'm just not, it's not coming to me right now. All right, so we have is adjacent. So if we are adjacent, we do nothing. Otherwise, we need to figure out, we need to move in some direction. And so we can do that. We can calculate our, how far we need to move in this way. So if we are, let's see, this is gonna be a positive or negative 1 or 2. Both of these, it's gonna be positive or negative 1 or 2. So I need to sort of normalize it down to a 1 or a 2. So I'm gonna write another little helper here. Now this one should be static, int n. And so this is gonna do if n is 0, we just return 0. Otherwise, we're going to return 1 or negative 1 depending on if it's positive or negative. So we'll check, is n greater than 0? If it is, we'll return 1. Otherwise, we'll return negative 1. All right, so we'll normalize this here. And then we can update our position. This dot set position is going to be our row plus our dist. This dot column equals plus c dist. I think that's how we update. So we can we figure out. Let's make sure this is working. Let's think about this. If, all right, so head is at position 2, 0. Tail was at position 0, 0. So tail, the head just moved up and the tail needs to move towards it. So our distance would be our head 2 minus this would get 2. So that'd be positive. If our head was below us, we'd be negative 2. So we got to move down 1. What about for column? If our column was 2, same thing. We need to increase by 1. Otherwise, we need to decrease 1. Okay, so we have here the set position for our follow. All right, I think that's essentially it. Now we just need to sort of read our input, pull out our moves, and process it. So I'm gonna write a static method here, public static. This is gonna parse moves. It's gonna parse in all of our moves. So we're gonna be taking in a string of rows. And let's do one that's public static parse move. We'll just do a parse move. We'll make it simple here, string row. And then once we have this just becomes list of, this just becomes return row dot select parse move dot to list. Yeah, okay. So we just got to do a single parse here, and then we can parse all of our moves in. So let's think about this. Parse move. We'll assume we're only receiving good inputs for brevity. We don't need to do error checking right now. We gotta split this into 2 tokens, the actual direction, and then the actual move. So we're gonna do int or string array tokens, so row dot split. Moves is equal to int dot parse tokens of 1. So that's the number of moves we need to generate. Oh, interesting here. This isn't quite gonna work because our move, we need a number of times to apply it. So I can't just do this. Let's have this. Parsing a single move is going to return a list as well. Is that what I want? Or do I want my move to incorporate that and then I'll do a loop on it some number of times? Or int times. We'll do a times here. And then this will make this a little bit easier. We can say tokens of 0 switch. And we'll just do R here. Goes to a new move of, if we're going right, we're gonna increase our column by 1 moves times. If we're going left, we're gonna do the opposite. We're gonna decrease -1 moves. If we are going up, we need to go up a row, so that's gonna be -1, new move, -1. And if we're going down, it's gonna be new move, +1 moves, like this. And if we get anything else, we're gonna throw new exception, something terrible happened. Okay, so building our moves, our actor actually needs to, rather than setting position once, we're gonna do for int I equals 0, I less than move dot times I plus plus. So we just got to repeat the move that many times. Okay, so we're going to repeat the move that many times. Let's see. Yeah, so we parse our moves. All right, so I think we can write we can try and write our first attempt at the program. We've done a lot of logicking here. Let me get a file, new file, example.txt. Paste that in here. So we're gonna get our list of moves. We're gonna construct this by doing move.parse moves. File.read all lines. We're going to read in all of our lines here from our example.txt. Then we're going to do we need to make a head actor. Head equals new head actor. For each move in moves, head dot move m. And then we get all of the positions that our tail's been in now. So console.writeLine tail dot head dot tail dot visited dot count. All right, let's .NET. I hope none of my students are watching. They'll yell at me because I haven't written any tests. Ooh, that's not right. 11. I think we're supposed to get 13. So we have some bug here. Let us, some bug. Let's take a look here at our actor. Let's make sure we add the initial position in. Let's go to our tail actor. Let's see if we can find it. Our dist, column dist. Gotta think through this a little bit. So let's look at okay, so in our loop, just to debug real quick, console.writeLine hang on. I'm just gonna do console dot right line m dot head, oops, head dot tail dot position. Oh, I gotta get row. A nice little helper here. Let's do a public int row int call position goes to row call. That'll be a nice little helper for us. Dot position, just so I can see what it is. And reason my way through it. All right. Yeah, something's not, because it should be the first time we move. It shouldn't move at all. It really shouldn't move at all. It should be 0, 0 the first time. So something is not. Oh, I think I know what it is. Oh no, it isn't that. Okay. So just to make sure I'm not crazy, this should produce all 0 positions 0. Okay. If it is adjacent, we should do nothing. We are adjacent if our distance is less than 2. Oh, this isn't. All right. I want my parse to work differently. Let's go back in time here. Let's go to my move. I want my move to be this so I can reason about it a little bit more easily. Yeah, so we're gonna move this in here. We're gonna get rid of this. We're gonna return moves at the end here. We're gonna create a list. Moves equals new. And this will be times. I'm gonna say for each string row in rows. We're gonna do this. Smab. Well, I woke up a little later than usual today. So nice to see you. I'm surprised you're still awake. I think I started like an hour and a half later than I have been on other days. So it may just be that, well, maybe you just didn't get a notification. That also could be it. It could just be that you were anticipating at a different time. I've only been streaming here for like 30 minutes anyway. Oh, that's fascinating. Well, I'm glad you're here. We don't want to return here. Instead, we want to add move equals Haas. I hope that's how you pronounce it. I am working on let's call this rows. I'm working on day 9 of the advent of code. So we have this little puzzle here where I'm on part 1 still. So you sort of have these 2 nodes. You have a head node and a tail node, and every time the head moves, the tail sort of responds. If it's adjacent to the head, so here's sort of a picture. If it's adjacent orthogonally or diagonally, the tail doesn't move. So we're like modeling rope physics. So if it's adjacent to it, it doesn't move. If it's more than one space away, it sort of follows it, but there's rules for how it follows. So if it's orthogonally away from it, so if the head is further to the right, it sort of follows it. And then if it is diagonally away, the tail needs to follow diagonally. So we're doing like a very simple physics simulation for 2 objects that are sort of attached to each other, and the head moves and the tail follows. So that's what we're coding. I have a little bug. I have a little bug here where I'm not, something's going on with my move. I think it's because I was parsing in big chunks. I'm gonna have my moves be individuals here. So right now I'm parsing in, our puzzle would get input that looks like this. It tells us how our head's gonna move. And right, left, up, down. Okay. In my head actor, I think I was doing something off here. Let's try again. I keep restarting my developer window instead of formatting. It's driving me crazy. There was some compiler issue earlier, so I had to restart my, all right, so .NET Run, move, actor, program. Now I'm really confused. I need to add this moves.add move. Okay. So we're parsing our input here into moves, and then my tail should be sort of following here. My tail actor, something's up with my tail actor's follow is not quite right. Or my is adjacent isn't quite right. So I'm trying to sort of debug that. It's really off. Or my example's wrong. R4. Oh, I'm just not parsing right. I have this silly bug here. All right, so this should be 4 int I equals 0, I less than times I plus plus. We're gonna parse this in that many times. We still get 11, but that's okay. That's what we were getting before. So we want to sort of think about how we should move relative to the head. So I'm just gonna debug this. We're gonna eyeball it first real quick here. So we have console.writeLine, head.position. So we're gonna say head like this, tail like that. We'll print out the move, console.writeLine, move, and then we will wait for some input just so I can eyeball it each time and think through what it should be. And hopefully I don't have to write a whole unit test, because that would be annoying. All right, so my head should move. Its column should update 1 and tail should not move. All right. Head should update and tail should follow. So there's the issue. So head updated, tail did not follow. So I must have some kind of off by 1 error. What am I? All right. Console. .writeLine distance. All right. Distance was 1. Distance was 2. Oh, here we go. Hang on. I just had my is adjacent wrong. So if these are 1, we happen to also be adjacent. There we go. All right, that should fix it. There we go. My is adjacent, I just wasn't thinking through how I was detecting adjacency to my parent. My brain, I just had my brain fog there. So now we are correctly detecting that. Let's go back to my program here. I'm think I'm close. And I get 13, which is what we want. I can take that little debug out there. I'm trying to be quick this morning because I woke up late. Well, I didn't wake up late. I just did some more stuff this morning. My partner, she is traveling later today, so I wanted to do something to prepare for that. I'm trying to be sweet. All right, 13. That looks good. Let's give it our full input. Fingers crossed. As what's the guy from Jurassic Park say? Hold on to your butt. Let me make a new input here. New file, input.txt, and we'll switch this to be input. And there's gonna be some really cool visualizations for this. I'm tempted to write my own visualizer. Hey, there's a gold star. All right, part 2. A rope snaps. Suddenly, the river is getting a lot closer than you remember. The bridge is still there, but some of the ropes that broke are now whipping towards you as you fall through the air. The ropes are moving too quickly to grab. You only have a few seconds to choose how to arc your body to avoid being hit. Fortunately, your simulation can be extended to support longer ropes. Rather than 2 knots, you now must simulate. Yes, Mab saying, I've inspired you. Correct. You've inspired me. You must now simulate a rope consisting of 10 knots. Okay, so I think I've built this in a nice way that's going to make it really easy to extend here. 1 knot is still the head of the rope and moves according to the series of motions. Each knot further down the rope follows the knot in front of it using the same rules as before. Using the same series of motions as the above example, but with the knots marked H 1 through 9, the motion now occurs as follows. Now you need to keep track of the positions of the new tail, the 9th, the 10th thing in the rope. All right, so using that input, we need to, how many positions does the tail of the rope visit? Okay, I can do that. I've done a good approach here. Let's wrap this as part 1. Void part 1. Smab, thank you for inspiring me. I appreciate it. And we'll do a part 2 here. And we're just gonna extend. I think it's gonna be super easy to do. We just have to, we'll call part 2 here. In our tail actor, now we have a head and another tail. So tail actor tail, like this, and we'll make this an optional. And we'll say tail, we'll add a second one here that says head, actor, parent, and then int children. So the number of children we have to do, we're gonna recursively construct this. If, and we can have it do tail, this with our parent. And then if children greater than 0, we're gonna say that our tail is equal to a new tail actor with this and children -1. Ooh, this needs to be just a generic actor. Hey, looks like I did that in a intelligent way. Looks like that subclass was important. And then after we follow, then we just have our tail follow. So we'll do this dot tail dot follow. So that should have our tail follow. And then we need to make it so that when we construct a head actor, we have a second constructor, public head actor int children. Where this dot tail equals new tail actor, this and children minus 1. We'll change this to the word length to make more sense. Length. Because it's going to be itself and then length minus 1. And then in my tail actor, do I have this? How many children? All right. We'll change this to length just because that makes more sense than children in my mind. Okay, I think if our code here is correct, then the only thing we need to change here is say we have a length of 10, and then we need to get the last element. Okay, so I'm gonna, we need to get the last thing. I just gotta do recursively say, okay, tail actor tail equals head dot tail. So we start with one tail, and then we say for while tail dot tail is not equal to null, tail equals tail dot tail. So recursively just pull out, get the last thing there. And then we're just gonna ask how many does the last element visit? 2179. All right, let's give that a shot. Oh no. Okay. What did I... How many... Do I have too many things? Did my logic on this make sense? How many, so we're gonna do int count equals 1 count plus plus. Do I just have too many things in my rope? Yeah, I think I have too many things in my rope. See if I get it this time. There we go. So length, why does that work that way? Did it in my actor, in my head actor? I'm not quite sure why I need to do 9. So I do length, if I give it 10, length minus 1. There's a small bug in there. If it's greater, oh, because if it's 1, we want to do, okay. So if I want this to work the way I want it to work, I would do it this way. All right, so I just want to do that quick fix there. To give myself some confidence. There we go. All right, 2 stars. Smab, thank you for the stars. I appreciate it. Let's check out your solution. Let's see how Smab did it. All right. I love that you have a whole framework set up. I should do better. I should do better. I love that you have these annotations here. Okay, let's look here. So load instruction. Instruction.parse. Where's instruction? Instruction.parse. Essentially the same thing I've done here. I had a little bug with just a regular move, so I broke it down into a little bit less. I've been working on a new solution framework so that annotations and loading only once is new. Cool. I think I like that a lot. I wish I've seen that in a lot of other people's solutions. I think that's a really cool way to build these up. So you're building up left, then we have an enum direction and tokens as int. Ooh, string has an as int. Is this yours extension, or is this something built into in C#? Gotcha. I like the way that reads, token as int instead of int.parse. Okay. We parse in all of our instructions. That's pretty straightforward. Let's look at, so you've modified your solution to take in a number of knots. Okay. Did you do that initially, or did you add that after you finished part 1? You went back and added that in. Tail points, point, head equals 0, point equals this. Pixel Pat, happy Friday, my friend. Or I'm guessing it's Friday where you are. It's Friday for me. It's early morning, but nice to see you, Pixel Pat. We are working on, we've just finished Advent of Code Day 9. I'm looking at my friend here, Smab UK's solution. We're comparing notes. Seeing how we each did it. Have you been doing Advent of Code at all, Pixel Pat? Are you familiar with Advent of Code? Let me ask that. So we have an instruction. For every instruction, we're gonna loop that number of times. And then, gotcha. So Advent of Code is like a programming, competition is a really strong word. There is a competitive aspect to it, but it is a cool set of, every year since 2015, this fella named Eric has gifted us with 25 problems. One problem a day, each day in December, starting on the 1st, and they unlock each day. You get to do some more. Today we're simulating rope physics. The puzzle was to simulate rope physics. And we just finished that up. There's 2 parts. Every puzzle has 2 parts. It has sort of like an easier part. I don't know if they're always easier. And then a harder part, or like you take the input and then you get the same input, but the puzzle has a twist on it. Thanks Pixel Pat. I appreciate that. We're comparing our solutions here. So I have no idea what a raid is, but sounds. So I appreciate that. I hope it's a good thing. I'm assuming it's a good thing if you tried to do it. Now you're here chatting with me. We're looping through instructions. Our instruction says to do a thing a number of times. We have a move head. And then for each of our tails, we move the tail. All right, so you're doing a more iterative approach. I like it though. Smab's doing a more iterative approach. Mine was kind of recursive. I have a recursive structure for each knot in my rope. Yours works well too, because it's iterating through it. Tail point stop. And then you're saying look at the position of the last knot and add it in. All right, so let's look at move head. Move head, super straightforward. We just shift it by whatever we happen to be shifting by. Question, Smab. Do you know the efficiency of using lenses like this? So in Haskell, in programming language, in functional programming language, when you have a record type, an immutable type like this, and you use a lens, in Haskell, the lenses are super smart, and it essentially counts as a mutation from a standpoint of memory allocation. Do you know Do you know how that works in C#? Is it, how efficient is this? Okay, it's supposed to be very smart. I didn't know that there was syntax to do lenses in C#, and I'm really this is really cool. This is really cool. I'm hoping this works as lenses. I'm gonna have to do some research on this. Awesome to see this syntax here. I've never seen that before. So the move that, and then move tail. Ooh, this is a smart way to do it. I like this way better than mine. So I was checking if it is adjacent. You're checking if it's not adjacent. You're checking if it's not adjacent. We know it's not adjacent if the distance of X distance or Y distance is greater than 1. I like that way better than mine. And then there's a built-in sign that I didn't know. I wrote a stupid normalize function because I didn't know what it was called, math.sign. So I'm gonna update mine here to reflect something I've learned. So instead of normalize, I can just do math.sign. Math.sign. I couldn't, oh, I can't delete those. This should be math. Oh, I still need this. Oh, so what I should do, hang on. Let's go back in time. Let's go back in time. Pixel Pat, if you're still around, I'd love to know what a rate is, or if anyone is in the chat that knows what a rate is. I don't know what that means because I'm fairly, I've only really started streaming the last couple weeks. Sign. Beautiful. I'm gonna try and commit that to memory here. Okay, so now I can get rid of this silly normalize method. Ah. Oh, that would have been really nice. Pixel Pat, if you're still around, I'm assuming you're not since you didn't respond. I'm curious what you were streaming before you decided to come over here. All right, let us. Follow. What was I doing? Oh, I was looking at your solution. Streaming is tough. I get distracted when I stream. I don't make a lot of progress sometimes. We have tail move. Yeah, nice. I really like your solution. Is so straightforward, so clean. Smab, super. Like, this is awesome. This is awesome. I think so. As you know, I do my tutorial videos, my beginner's guides. I think I'm gonna use your approach, if you don't mind. I really love your approach here without classes. I'm trying to keep it simple, as approachable to beginners as possible. So it may not make sense to model the data in this way, right? So just modeling it here using this data. Do you have like a position? How are we doing tail width? Am I missing something here? Tail point. Is this built into, I'm assuming point is something that you've written where it just has like an X and a Y position. It's a record type with an X and a Y is my guess. Let me know if that's true. Yeah, so I'm trying to keep my guides not specific to any paradigm, so object-oriented. If I can avoid it, I want to. Just to give it a more generalized approach. So although my solutions are sort of in C#, it is something that I want people who are using other languages to be able to watch and sort of break it down like, oh, okay. So is adjacent is actually going to sort of take in two points, and it'll just tell us whether or not they're adjacent. follow is going to take in sort of a head and tail node, and then it will return like the position that you should move to. Yeah, so a more, I guess that would be called procedural. Very cool. Nice solution. I'm glad I was able to get through this so quickly. I was a little worried that we were going to have a challenge that I wasn't going to be able to finish on stream this morning, because I do have to hop off here and prep for my class. Got started a little bit late, but we made it through. We got some stars. Let's add in. That's it. I'm going to do a commit, and then I'll be happy. I might clean it up a little bit before I do a commit, but I'm really happy with it. Smab, anyone else who's out there in the aether, thanks for watching. This was fun. Thanks for hanging out with me. And as always, have a beautiful day. Smab, get some rest. And I will... Oh, helpers. Very cool. I'm learning so much from your code, by the way, so I appreciate that. How long have you been doing C#, Smab? Just curious, out of curiosity. Because I just haven't been doing C# very long, and I haven't used C#. The real downside is I haven't used C# in a professional capacity on any sort of project with other developers. Something I always tell my students is one of the best ways to learn is to work on projects with other people. Go look at open source projects, contribute to something, and you will learn so much from people who have been developing that language, because they know all the tricks. They know all the tricks and secrets. You don't get sort of stuck in sort of whatever set of things you've done. Awesome. Well, thanks again. I'm hopping off here. Have a beautiful day. Get some rest. I'll see you next time.